When I start a problem involving the GCF and LCM of a set of monomials, the first thing I need to do, regardless of the number of monomials present, is to do factor trees for any numbers. So when I look at the factor tree for 48, I end up with 2 to the 4th times 3, and then don't forget the x to the 4th. So inside of 48, there's 4 2's and a 3. I do the same process for 27 and find out it's 3 to the 3rd and x to the 3rd, y to the 6th. This form in blue here is much more usable because now I can see all the pieces that are inside of these composite numbers. So before I do anything with GCF LCM, I need to remember how to find each of them. For the GCF, I'm looking for what they share in common. And when I say in common, I mean all of them have to share it. So what does everybody have? So if I look at the GCF in this case, I look at each of these sets and I say, well, the first one has a 2, but the second monomial doesn't have a 2, so they do not share it in common. They each have a 3, but how many 3's do they each have? Well, the maximum that they each have is just 1 because of this piece right here. They each share some x's, but they only share 3 x's in common because the second monomial only has 3 x's. And then even though the second monomial has some y's, the first one doesn't. So my GCF is 3x to the 3rd. When I consider LCM, what I'm really looking for is the highest power of every term I see. So LCM is kind of like a game of I Spy. I go through and I start to look at what's there. And I spy a 2, a 3, an x, and a y. Those are all the pieces I spy. And then I look for the highest powers of each. So for 2, it's 4. For 3, it's 3. For x, it's 4. And for y, it's 6. So my final answer is 2 to the 4th times 3 to the 3rd times x to the 4th times y to the 6th. And I could go ahead and multiply out 2 to the 4th times 3 to the 3rd, but I'm going to leave it in exponent form. Now when I take this same process, I can apply it directly to a set of 3 monomials. So I have some pretty big numbers here, but with a little time and a little effort, I can do factor trees, and I can realize that 4032 really has 6 2's inside of it, it has 2 3's, and it has a 7. And don't forget the x's, the y's, and the z's that go along with them. For the 19,600, it's really 4 2's times 5 squared times 7 squared. X to the 3rd, y to the 3rd, z to the 4th. Again, the factor trees aren't difficult, they just take a little time and effort. Lastly, 3,360 really has 2 to the 5th times 3 times 5 times 7. And then x, y to the 6th, z to the 3rd. That's the hardest part of the whole problem, is getting those factor trees correct. Now it's really just a game of looking to see, for the GCF, what do they have in common? They each have a 2, and they only share 4 2's in common because this term only has 4 2's. They don't each have a 3 because the 3 is missing in the second piece. They don't all have 5's because the 5 is missing in the first piece. But they do all have 7's. And the most 7's they share is 1 7 from the last piece, so 7 to the 1st. Then I consider the x's. They all have x's, but the most they share in common again is 1 due to that piece. They all have y's, and the most they share in common is 3, right there. And they all have z's, but the most they share in common is 3 from either that piece or that piece. So my GCF is 2 to the 4th times 7, x, y to the 3rd, z to the 3rd. That's my GCF. For the LCM, I go through and play I Spy. So I see a 2, a 3, a 5, a 7, an x, a y, and a z. Those are all the different terms I see. And then start picking out the highest powers. Highest power on 2 is a 6. Highest power on 3 is a 2, which is the only power on a 3. Highest power on 5 is also a 2. Highest power on 7 is a 2. The highest power on an x is a 4. And the highest power on y is a 9. Last but not least, the highest power on a z is a 4. So the LCM for this set of 3 monomials is 2 to the 6th times 3 squared times 5 squared times 7 squared, x to the 4th, y to the 9th, z to the 4th. If I were to multiply that all out, it would be a very large number. So I'm just going to leave it in exponent form. This same process can be used with however many different monomials you have. It's not limited to 3. It can still be used as long as you do a factor tree and then just look for the right things in your problem.